The primary health issue that we're really interested in our lab is looking at how different medical devices like artificial hearts basically change the blood cells' function and properties.
We always thought that we'd put a blood pump into a patient and all their problems would be solved. They'd go home, they'd be healthy, etc. And that's not the case.
The physical forces within artificial organs really change the way that the cells behave. Basically, they're much less flexible, and also secondly, they start to clump together. Now, these two things basically make the blood more viscous and less able to flow through the body.
So what we're doing is we're playing with a very specific set of bearings. It's called a spiral groove bearing. It's really very novel, and I've got visitors now from Japan and from the United States here in the laboratory, all of us trying to work out exactly how the mechanics of these things work and to understand just how protective this sort of bearing can be to the blood. I'd been doing quite a lot of work in sort of biorheology, trying to model how blood flows through these devices. Mike's developed quite a world-renowned expertise in that area, so it seemed logical that we should eventually find each other.
And we actually were at the same campus and had just never run into each other. So we actually met and started working together on some new experiments, and it's led to us forming the Mechanobiology Research Laboratory. And so we're trying to address really important health and medical problems from very different perspectives, and this is extremely rewarding.
There's just too much to know for one discipline to be able to make any inroads these days. So I think multidisciplinary research is the way that we're going to make big breakthroughs in the future.
The primary benefits of our research working with different disciplines will ultimately lead to some great economic as well as health outcomes. In the first instance, we hope to create new generations of medical devices that are basically more friendly to blood. We hope that the 1 million people that receive cardiovascular interventions around the world that require artificial organs will basically benefit from not having their blood being damaged.
These devices would go in, the patients wouldn't have to keep going back to hospital, and all the associated costs with that. So it would be really quite significant.